Alright, so quiz 11B, and I don't even remember how much we went over yesterday in class, probably not a whole lot. Straight rules, you just got to know your rules. Some of you did not have the parentheses right here on 1C. The parentheses is necessary. Technically, without the parentheses, you have a whole different value, and so that's easy to fix. Some of you didn't know this, what to do when your radicand is a fraction. Well, be careful, because then any problem with a fractional radicand you're going to miss. So you got to get that cured for. Okay, what can I explain for you as to anything else on the front? What other questions do you have of things on the front? Now, numbers of you missed numbers of questions on the front, so there should be numbers of questions right now on what went wrong and why the answer was the answer. So questions on the front. Jack. So the thought process is you're going to use the Pythagorean theorem to verify if it's a right triangle or not. And so in using the Pythagorean theorem, you're going to say a squared plus b squared equals c squared. Now, Jack, out of those three sides, which side has to be which letter? There's one side that has to be one of those three letters. You know which? C has to be, and which one of those three sides is the C on the triangle? It is the 8. Again, the C is always the longest side. We don't know that it's across from the right angle right now because we don't know it's a right triangle. But you got to use the 8 in for the C. All right, A and B, if you use 7 for the A, fine, and most did, and the square root of 15 for the B. But remember, these are both squared. 7 squared is 49. Jack, what do squares do to square roots? They undo them, so the answer is always the radicand. And 8 squared is 64. 49 and 15 is 64. 64 equals 64. Therefore, because it's a true equation, because the Pythagorean theorem works, it is a right triangle. Some of you tried to use the square root of 15 in the wrong spot. Some of you didn't square some of the sides, and that's what goofed you up on that one. All right, what else on the front? What else on the front? This section did not go well for numbers of you. Questions? Questions? Andrew? All right, so I know time was limited yesterday when I got into this. So what happened was, here's the issue. Everybody needs to pay attention to this. Here's the issue with number 5. Do you immediately split it up? And the answer is no. And how do you know? See, that's the tough part sometimes with students. How do you know? And the reason you know is that's reducible. If the fraction in the radicand can be reduced, reduce it first before splitting it up. Hence, you end up with 7 over 28 is 1 over 4. By the way, one of you guys just ended up with 4. Well, the 4 is in the denominator. It's in the bottom. I don't know how you made it float to the top magically, but maybe you got to talk to Elijah or Elisha in the floating accent. But it's a 1/4, right? So square root of 1 over square root of 4. What's the square root of 1? 1. What's the square root of 4? 2. And that's how we get there. But the key to that problem is looking at it and say, oh, I can reduce that denominator, that fraction. So I can reduce it. Let me reduce it before I split it up. What else? 2 through 8. 2 through 8. Lauren? Okay, so number 4 now, it would be the exact same thought process. You look at 36 and 25 and you say, hey, that doesn't reduce. So now your only recourse is to split it up. So see, we're using this rule right here, rule 1b. So we split it up. And now we say the square root of 36 is 6, and the square root of 25 is 5. And we end up with 6/5. What else on the front, Gabe?
Number 8.
Go a little higher with 8 here. All right, remember, guys, be careful. The index tells you what kind of root it is. So you're looking for, Gabe, what times itself 3 times. And the way we simplify all our radicals is to factor the radicand. So I don't know how you do a 54. Maybe you do 2 times 27. Whatever. 27, I think of 3 times 9. And 9, I think of 3 times 3. Well, now I see I have 3 3's. And what's the cube root of 3 3's? You get a 3 out front. Does this 2 come out? No, there's only one of them, so what's left? The cube root of 2, 3 times the cube root of 2. What else on the front? Anything else on the front? Anybody? Blake? All right, so look, everybody pay attention here, because this is what will happen to you guys on your test as well. So you go through number 2 and you remember, how do you multiply radicals? You multiply the radicands. However, you have to remember that you also want to look to simplify. Well, number 2 is just a 2 and a 7. However, if you look at number 3, you'll realize a 6 is a 2 times 3, and a 15 is a 3 times 5. And you'll realize you can take the root of the 2 3's. What's the square root of 3 times 3? It's this 3 right here. And what's left? The square root of 10. Now remember, we're doing a little shortcut for sticking them all underneath the same one, but it's, look, the exact same thing, right? You get a 3 out, and you got a square root of 10 left in. So what you guys have to be careful about is, when you can simplify, simplify. All right? How many of you didn't simplify that? It was a lot of you. You got the square root of 45. Yeah, so you always got to be looking to simplify. Anything else on the front? Anything else on the front? Anybody? All right, on the back, 10 or the bonus. Lauren? All right, so again, you look at 10 and you say to yourself, self-Pythagorean theorem. And you say to yourself, a squared plus b squared equals c squared. C has to be the 9, because the 9 is opposite the right angle. A could be any of the numbers. I'm going to put the A as the X, I'll put the 6 as the B, and I'll put the 9 as the C. Okay, here's your thought process. Oh, I have an exponential equation. Let me go ahead and simplify what I can. 6 squared is 36. 9 squared, 9 times 9 is 81. Things added to the variable, you move by adding their opposite to both sides. I'm seeking to isolate the squared term. At this point, how do you get to x? You must take the square root of both sides. And normally, we would put a plus minus, but this is a triangle, and the distance of a triangle can't be negative, so we don't worry about the negative part. Square root of x squared is x, but the last thing to do here again is, can I simplify square root of 45? Well, it's a 5 times 9. What's the square root of 9? It's a 3, and we end up with 3 times the square root of 5. Anybody need the bonus? Anybody want the bonus? Any takers? Bonus? Okay, so bonus was a simplification process. Again, remember, whenever you're adding radicals, they must be exactly the same. Same index, same radicand. Can you add a square root of 2 with a cube root of 2? Yes or no? No. Well, these are all square roots. So it looks like right now I can definitely add this one and this one, right? They're ready to roll. And the middle one doesn't look like it yet. But what's an 18? A 2 times 9. What's the square root of 9? 3. I get a 3 out. So let me rewrite what we've got. Negative square root of 2 plus 3 times 3 is 9. 9 times the square root of 2 minus 8 times the square root of 2. All right, let's add them up. This is a negative one of them, right? Negative 1 of them and positive 9 of them leaves me positive 8 of them. Positive 8 of them and negative 8 of them leaves me nothing. They're gone. I had 8 positives of them and 8 negatives of them. They're opposite numbers, 0. Right? 5 apples minus 5 apples, you got nothing left. They're all gone. And if you want to do it mathematically and say 0 times the square root of 2, that is true. But what's 0 times anything? 0. And the final answer is 0. Jack. No, it's fine. I'm just trying to make sure that you understand why it ends up there. Okay? All right, so keep that quiz. Hopefully you still have quiz 11A, and those are going to help you. Let's go ahead and go through some chapter review. Chapter review. All right, if you're watching by way of video, you're probably going to want to pause often. Otherwise, there'll be a lot of lag time in between. Okay, so terminology. You know I'm going to ask you terminology. So somebody tell me, raise your hand, what is the blue symbol called? What is the blue symbol? Raquel? No. But at least you tried. Pamela? It is the radical sign. You commonly call it a square root, but a square root's only one kind of radical sign. And this one's not even a square root. All right, what is the name of everything underneath the radical sign? What do we call that? Lauren? The radicand. Got a D on the end of that word, right? Radicand. And who's going to tell me what goes in the crevice? Kaylin? The index. So this has an index of n, so it's definitely not a square root. Right? It's an nth root. Not a square root. What number times itself n times equals the radicand. All right, just make sure you know your terminology. It helps when you hear me talk about things because I'm going to use those terms. All right, go ahead and go through and do 2a and 2b. It says find all roots. And by the way, if you look on your sheet, question 3 says find the principal roots. So that should tell you 2 and 3 are a little different. See what you can do. Why don't you do 2a, 2b, and just pause, and then I'll deal with 3a and 3b. All right, on 3, class, tell me your answer to 2a. All right, on 3. Here we go. 1, 2, 3. And I think I heard a couple people say plus or minus 2. And that would be the answer to 2a if we asked you for all roots. Sounds like a lot of you gave the answer of just the principal root, which is normally all we give. So don't feel so bad. That's normally all we give. A lot of times when they ask you for the answer to the root, Adriana, can you get my door for me? Usually when they ask you for an answer to a root, they really only want the principal root. But I use the word all, and that should tip you off. So then 3a, if all is plus or minus 2, by law of deduction, a little bit of common sense, on 3, give me your answer to 3a. Here we go. 1, 2, 3. Yeah, that one's just the positive part, okay? So therefore then, now go back and correct 2b. Probably everybody's going to get it right now, right? Because you're all going to say plus or minus 10. All right, so principal root means just the positive. And oftentimes when they want you to solve, they just want the principal root. 3b will be plus or minus 6. Jordan. Which one? You can write it out in 2 separate answers because that's really what the plus or minus means. Because, Jordan, positive 2 times positive 2 equals a radicand of 4. And A negative 2 times a negative 2 also equals a radicand of 4. They both are the number times itself 2 times that equals the radicand. Remember, this format writes two answers at one time. It means the positive 2 is one of the answers, the negative 2 is the other. Andrew. Thank you. No Kool-Aid for Andrew. Principal root, right? 3b is just a 6. All right, any other questions on these? So again, be careful when we ask for the principal root. We only want the positive one, and normally that's the situation. Okay, figured I'd bring that out so that you guys are good there. All right, next we got into some radical equations. Radical equations. So just do 4a and stop. Don't do 4b yet. See if you can do 4a. Think about how we solve equations and how we solve radical equations. See if you can get it. Are you there? I don't know what the answer is, but on 3, give me your answer. 1, 2, 3. All right, I hear a lot of 5s. Let's see if you're right. So hopefully you said to yourself, self, I need to isolate the radical. That's what you're after, right? Move things added to the radical by adding their opposite to both sides. What in the world? Where did I get 5 from? It's like, that doesn't even make sense. Oh, well. What the brain does at times, who can figure it out? I don't know. All right, so hopefully we end up with the square root of x minus 1 equals 2. You say, oh, good, self, I have just isolated the radical. Now I'm ready to square both sides. Squares undo square roots. The answer is the radicand. And I'll finish by moving that 1. And yeah, I heard a lot of 5s. So how many got that right? There's a bunch of you. All right, good job. So take that knowledge and go ahead and do B. All right, and if you didn't get it right, now use that knowledge so you can get B. Go ahead and do 4B. Not snorting. Okay, so again, same process. You're going to say to yourself, self, I need to isolate the radical. When things are both added to and multiplied times the radical, I'll move things added first. So you added negative 7 to both sides. And let me pause right here. Everybody look at this screen. Hey, right now it's looking like we're going to have no solution because we're going to try to square the other side when it's a negative. But remember, we're not done yet. We need to move this negative 2. And when I do, we do end up with a positive result, and that's important. All right, my radical is isolated. I can now square both sides. 3x equals 25. And again, things multiplied times a variable. You multiply by the reciprocal, or you do the shortcut. And how many ended up with x equals 25 thirds? All right, all you correct people. And if not, somewhere along that line you made a mistake. But same process. Things added, you move by adding their opposite. Any questions on that? Anybody? Any questions on that? Jack? There could be nothing there or anything there. It could be a 5, a 7, an 11, a 37, a 387,000. This one had nothing in front of the radical symbol. Well, remember, Jack, anything in front of a radical symbol means multiplication. We don't put a raised dot there. We could. And anything multiplied times the radical, you move by multiplying both sides by the reciprocal. Just like you would if you had a negative 2x equals a negative 10. To solve that equation, you'd either multiply both sides by the reciprocal, or you'd do the shortcut, if I can get all these erased, of dividing both sides by negative 2. No difference. Multiplied times a variable or multiplied times a radical. Does that answer your question? Okay. All right, let's do the last two. So these are a little different, right? These are exponential equations. Your variable is squared. So try A. Go ahead and see if you can solve A. Solve A. Again, I'm going to pause the video. So you may want to pause at home if you want to try it. All right, on 3, nice and loud, and I don't know what the answer is yet, but I want you to give me the answer nice and loud on 3. 1, 2, 3. All right, quiet, please. He still doesn't know, does he, that I'm looking right at him, does he? He's clueless, right? You're clueless back there, Mr. Sam. All right, look at that, and you're going to say, hey, I'm going to isolate the squared term. Things added to the squared term, I'll move by adding their opposite to both sides. Once my squared term is isolated, I'm going to take the square root of both sides, and I heard some of you rightly include the plus minus. A lot of you are going to lose a lot of points if you do not include the plus minus because you did not give all the solutions. How many had plus minus 3? Okay. And the rest of you hopefully will not forget next time. I hope. I hope. All right, try 5B. All right, we'll see. All right, so you look at it again, you say to yourself, I need to isolate the squared term. Things added to the squared term, I'll move by adding their opposite to both sides. Things multiplied times the squared term, I'll move by multiplying both sides of the reciprocal, or I can do the shortcut. All right, let me rewrite where I'm at right now. I am here. I am now ready to take the square root of both sides. Plus minus, right? Now I hope you continued on. How many continued on past this? Because here's where you're at right now. Plus or minus the square root of 9 over the square root of 4, remembering the rule of a fractional radicand. Now there is no reducing before this, so I'm ready to split it up. And I will remind you, the plus minus needs to only go with one of them. Your ultimate answer is going to be plus minus. Let me do it underneath. So you're going to end up with n equals plus or minus square root of 9 is 3, square root of 4 is 2. Plus or minus 3/2. How many had that correct? Let me see your hands. And look, we can all do that. Square root of 9 over 4. Square root of 9 over square root of 4. That's why we learn the rules. So we can apply the rules when the situations arise. Questions on that? Any questions on that? Jack? Mm-hmm. Mm-hmm. You can get away with that procedure on this one because that 4 easily takes the square root, but it only works in that scenario, and therefore it's not wise to do. But on this one, you could have ended up with the correct answer. All right, let's do the second page or the back of your page there. All right, so somebody raise your hand when you see a problem like this. What's the first thought that pops into your head? What pops into your head? Alexandra? Pythagorean theorem. All right, go ahead and use the Pythagorean theorem and solve 6a. Use that Pythagorean theorem and solve 6a. I'm pausing. All right, I know some of you may not be done yet, but I got to speed up a little bit here because I want to get some things at the end. Hopefully the key is you made the x the hypotenuse, right? The c, it's got to be there. 4 and the 8 are interchangeable. So the way to proceed, usually you'll simplify 1664 equals x squared. 64, 74, that's an 80 equals x squared. Now I'm ready to take the square root of both sides, right? No plus minus because distance isn't negative for a triangle. Now what else am I going to do here at the end? I'm going to look at that 80 and say, can I simplify an 80? How about 4 times 20? What's the square root of 4, class? 2. Oh, I got a 2 out already. And what's a 20? 4 times 5. What's the square root of 4 again? I get another 2 out. So I know I'm running out of room here. But your final answer is 2 times 2 is 4 times the square root of 5 equals x. That would be the final answer in simplified form. Square root of 80 is correct, but you always want to see if you can simplify your radicals. And you guys in pre-algebra, that would be a minor deduction on a problem like this. If you get all the way to the square root of 80, you'll get most of the points, but you want to try to finish to get them all. All right? All right, I really don't have time to deal with B. The only difference there is in B, you're not solving for the hypotenuse, are you? Again, you're going to do it the same way. A squared plus B squared equals C squared. The difference is 10 is the C there, and you can call the AZ or the BZ. It doesn't matter. BZ, that's funny. Again, you're going to isolate your squared term. This time, though, notice when you get that 36, you'll be adding a negative 36 to both sides. You're going to end up with 100 minus 36. What is that? 64. Oh, this one's going to work out nice. You're going to have z squared equals the square root of 64. So z equals square root of 64, and z is going to be 8 on that if you were to finish it out. All right, when you see a question like number 7, do you remember what to do? Is a triangle with sides 11, 6, 9 a right triangle? What are we going to use to figure this out, yes or no? Raquel? All right, tell me the formula. Correct. So she's going to use a squared plus b squared equals c squared, which is the Pythagorean theorem. And out of this, what's the key to making sure we use it correctly? What's got to go where? Gabe?
The hypotenuse has to go on the right side.
And which one is the hypotenuse? 11. It has to be the 11 because it's the biggest one. All right? So again, you would play with the numbers and see if the left number equals the right number. I know we get a 121 on the right. What do we get? 36 and 81 equals 121. Close, but not quite, right? So you would say no. It was close, but we weren't quite there. All right, let me get to this last section, because this is the section that gave you guys trouble on your quiz, right? And you're definitely going to see this kind of stuff again on your test. All right, for time's sake, I'm just going to direct you. Problem like this, we need to deal with first. Remember, underneath a radical sign, follow what? What would you follow under the radical sign? Somebody raise your hand and tell me. Nick? Order of operations, right? So you would definitely do the 4 times 5 first. Now we end up with the square root of 25. And we all know the answer to that is 5. Again, we normally do the principal root. On this other part, we can take the square root of 4, right? Square root of 4 is 2. Don't lose your negative sign, agreed? We end up with 5 minus 14. Does that make sense to you guys? And therefore, everybody would finish out and say the answer is negative 9. 5 positives and 14 negatives leaves me 9 negatives. All right, so that was one where when we simplified, there were no radicals left. That's not the case for B. B is adding radicals. All right, see what you get for B. Go ahead and do that one. See what you get with B. You should be done, and if you're not, something's a little off. Because all this is adding like terms. Negative 4 of them and another negative 1 of them is a negative 5 of them. Agreed? However, that's the final answer. How many got it? We can't add a square root of 3 with a cube root of 3. They do not add. They're not like stuff. Okay? So those do not add because one's a square root and one's a cube root. The indexes have to match. The radicands have to match. It's just different things. Again, it's like adding 3 cents and 5 chiclets. All right? They don't add. You still have 3 cents and 5 chiclets. I don't know why that popped into my head, but anyhow. All right. All right, try C. 8C. Just going to give you a minute on this one. Try 8C. you're doing something on your calculator, it's not wise. You got to learn what to do. Unfortunately, today calculators do too much and they make the students dumb. You say, how so? It makes me smart. No, because as soon as we put variables in there, now you have no earthly clue what to do when you should have been learning how to do it on easy numbers. So don't let the calculator dumb you down. All right, for time's sake, you should have looked at this and said, I'm going to simplify before I multiply. S-bum. 6, 2 times 3. 30. 3 times 10. 10, 2 times 5. Look at this thing. 1 3 and 2 3s. I get a 3 out. 1 2 and 2 2s. I get a 2 out. And what do I have left in? Square root of 5. Final answer. 6 times square root of 5. And if you learn how to do it with numbers, you'll be able to do it with variables, and that's where we're heading next year, to variables. Nick? What do you mean cancel them out? I am taking the root. I'm not canceling anything out. I'm taking the square root. The square root means what number times itself 2 times equals a factor of the radicand. So whenever you have a 2 times 2, the square root of it is a 2. A 2 times itself 2 times a 2 times 2. Whenever you have a 3 times 3, the square root of a 3 times 3 is a 3. I'm actually doing the square root of it. I'm taking the root. I'm doing the operation. Okay? I'm not canceling anything out. All right, how about D? Try D. Only got a minute left here, so I'm going to pause you already. Let's see if you started correctly. Did you split it up or did you reduce it? Again, no, you got to look to reduce first. If it reduces, reduce it. That's a 2 comes out of the top and a 2 out of the bottom. Now split it. Square root of 7 over square root of 25. The top's got to stay, right? But what's the bottom? A 5. You should have gotten the square root of 7 over 5. So you can be careful on that kind of problem. Whenever you can reduce the fraction, reduce the fraction. And then split it up. All right, last one is a cube root. For time's sake, I'm just going to guide you through it. Watch, everybody. I just got a minute, so watch me, okay? First off, remember we learned whenever there's a negative, then the root has to be negative. So I'm going to stick it out front, and now I don't have to worry about it anymore. That's the best way. Now I'm just going to deal with the numbers. 24 is what, a 4 times 8? It's a 3 times 8. Yeah, and 8 is a, hey, I'm just going to take, what's the cube root of 8? You guys know it? 2. All right, 2's out. See, I took the root. I still have 1 3 left in. Let me deal with my 45. 3 times, whoa, 5 times 9 is 45. Slow down. And a 9 is a 3 times 3. All right, so again, I'm looking, I've got a cube root, right? I need 3 of them. Oh, look, 1 3, 2 3s, 3 3s. Cube root of 3 times 3 times 3 is 3. What do I have left in? The cube root of 5, final answer, negative 6 times the cube root of 5. Hey, guys, listen, be careful this chapter. Almost everything we've done is new information for your brain. And I hate to say it, I don't want to make you feel bad, but almost nobody in here has a good enough memory to remember without much review. Stop. Don't pack up. That's why you had a rough quiz yesterday. Because we had a whole chapter of new material. We learned lots of things. Right? That's a lot of stuff we covered today. We learned lots of things. How are you going to remember it? You got to review. You got to review. Do that before Monday or Tuesday's test. All right, now you can pack up.